Good day all. Scott Norina here. In this video, I will be talking about a programming exercise I have developed using TypeScript. As you may know, I am principally a Java developer working on web applications using Spring Boot. This web page is an example profile page from my Java web application, subs2go.ca. This page was generated from a back-end server running a Java Spring Boot application. The data displayed here was pulled from a MySQL database. Although most of the web pages I have coded are generated using the server-side template engine Thymeleaf, given specific application requirements, it has been necessary to include some front-end programming using JavaScript. While studying JavaScript, I have learned of a massive ecosystem of JavaScript-related frameworks. It has become apparent that many programmers lean heavily on JavaScript frameworks for their program coding. The sheer number of frameworks is overwhelming. Many of these tools work with either JavaScript or TypeScript, but they also include a huge amount of framework-specific programming code syntax. Apparently, some programmers spend so much time working with framework-specific code syntax, they do not learn of the particulars of the underlying TypeScript or JavaScript code. This is problematic, especially if circumstances force the use of vanilla JavaScript or TypeScript, or if an application must be rebuilt using a different framework. While using a framework might speed up development initially, significant problems may occur down the line, especially if the code base becomes large and complicated. If a framework upgrade or change were necessary, it could take significant time to refactor. There may not be any good reason to use a framework at all if your application can be coded with vanilla JavaScript or TypeScript. The question then appears to be which language to learn and why. The reason for the incredible number of JavaScript frameworks would seem to be due in part to the serious shortcomings of the language itself. Consequently, I would argue that TypeScript is the way to go. TypeScript is an excellent programming language for large-scale applications and is specifically designed to address the challenges that arise when JavaScript projects grow in size and complexity. Today, both front-end and back-end code may be written using the same programming language. The back-end runtime environments of Node, Deno, or Bun may be used to run programs written in TypeScript. While TypeScript must still be compiled down to JavaScript to be run on the front end in a web browser, it is a relatively simple matter to include a compilation step in your programming workflow. TypeScript is a very good language to learn for an aspiring full-stack developer. It is a very compelling argument to be able to use one programming language for both the front end and back end. Another good reason to use TypeScript is the inclusion of type safety. TypeScript is a superset of JavaScript that includes static data types. TypeScript type errors may be caught in your code editor or in the compilation process. The bottom line is a TypeScript code base should be higher quality and more reliable, especially in large complex applications. Alright, if you are still watching, I assume you are interested to learn something about TypeScript programming. Let's talk about my programming exercise. All the program code will be available for download from a public Git repository. The link will be copied into the video description below. The purpose of this exercise is to demonstrate how a TypeScript application can be written and executed in both a front-end client web browser and on the back end. The application will simulate a database of users and output the user data in a terminal window and in a web browser. Before we look at the program code, I will explain how to install a number of dependencies used for TypeScript development. I am programming on a Windows machine and I use the following tools. Chocolatey is a package manager I use to install Deno, Git, and NeoVim. LunarVim is also installed and is used as my programming IDE. NVM, Node Version Manager, used to install Node. Run the command nvm list in a terminal to see the list of Node versions installed on your system. npm init is used to initialize a Node program that may use Node modules. It will also create a package.json file in the root directory that will be used to define a number of scripts useful for our TypeScript programming workflow. For example, we will create a script configured to compile our TypeScript code into JavaScript and execute the program inside a web browser. The node npm command is used to install pnpm globally and is used as an alternate to npm. npm install gpnpm. Scripts defined in the package.json file may be executed with either nmv or pnmp on the command line. expnpm run server or node run server. pnpm is an optional alternative to npm. The use of pnpm to install node modules saves disk space by connecting previously downloaded modules through symbolic linkage from a local cache to the node module directory in your application code. pnpm will only download and install a required node module if it is not already available locally. Dino and Node are installed locally and can be used to run our TypeScript code directly. I have Dino version 2.4.4 installed, but any version will suffice. Node version 2.3.11.0 is installed. Only recent versions of Node are capable of executing TypeScript code. I will use these runtimes later to demonstrate execution of our program with data output displayed in a terminal window. pnpm is used to install the following node modules: asbuild, JavaScript obfuscator, live server and TypeScript. Asbuild will be used to compile our TypeScript code down to JavaScript. JavaScript obfuscator is used to optimize and obfuscate our JavaScript code prior to release to production. Live server is used to serve our application in a web browser from our development environment. TypeScript is installed and used for type checking. The TypeScript tsc command may also be used for compilation, but we are using asbuild instead. Any text editor or alternate IDE integrated development environment may be used if you do not wish to install neovim/lunarvim. You may download the Git repository for my code or clone the repository on your computer. The link to this public Git repository will be copied into the video description below. Okay. Let's take a look at the program files and directory. I will open the TypeScript files in the src folder that make up the essential code of this program exercise. We will examine the code in these files in detail. In particular, we will look the program execution path. We will also examine the syntax of data types and the use of ECMAScript modules to organize files and code into separate reusable component parts. The index.ts file is the entry point of the application. This file includes a simple if-else control statement. The statement checks for the existence of a window object. A window object only exists in a browser environment, therefore if the code is run in a web browser, the control flow check returns true and the generate HTML function is executed. Otherwise the control flow moves the execution to the else block where the displayDetainDev console function is executed for display of the user data in a terminal or console. Notice that the functions on both sides of the if-else control flow are imported from other files in the src folder. These import statements have a counterpart export statement in the referenced source file. Program code is made reusable through these ECMAScript module import and export statements. Output to html.ts contains all code used to generate the HTML components of our application displayed in a web browser. This file must be compiled into JavaScript before it can be loaded and run in a web browser. Run of this file in a terminal will fail due to the fact that the HTML objects created here do not exist in a terminal environment. This file uses an import statement to access the user data array and custom type, username. DisplayData.ts contains code used to output a list of user data in a terminal window or console. This file includes three types of program loops, for each and traditional index loop. Each loop iterates over our user data array and console logs the user details to a terminal window. String interpolation is used in these loops to convert user object data fields for console log output. Data.ts includes code to define a function that creates seed data for 5 user objects contained in an array. This function is used to simulate return of data from a backend database server such as PostgreSQL or MySQL. Types.ts includes a custom data object type that defines 3 fields to be used in our user data objects. TypeScript is essentially JavaScript with a static typing system. Everything that can be assigned to a variable, such as number, string, booleans, arrays, objects and functions, has a type. It is also possible to create custom types that may be exported as modules for use throughout the codebase. The username type defined in the types.ts file is an example of a custom type used in this program exercise. The username type itself includes 3 fields that each are defined with a variable name and a data type, ID of type number, first name of type string and last name of type string. By exporting username from the types.ts module, this custom type is available for import into other TypeScript files in our program codebase. For example, the username type is imported for use in the data.ts file. By typing the 5C data user objects as username, each of these objects must be instantiated including the 3 required fields with data of the appropriate type. Any attempt to apply an incorrect value into a type variable will show as a coding error in your IDE and/or cause a failure in the compilation process. By adding static type information and separating the functional parts of our code base into reusable modules, our TypeScript program will be less error-prone and more easily managed in the development process. Okay. Let's see the program in action. Here we will run the code. Firstly, we'll execute the TypeScript code directly on the backend with Deno and Node. The program control flow if-else statement in the index.ts file will direct the program to output our user data to the terminal window in a Node or Deno runtime environment. As mentioned previously, TypeScript is a first-class language in a Deno runtime. However, it has only been possible to run TypeScript code with Node since version 22.6. Notice that the entry point is the index.ts file. Within the index file, we use ECMAScript module import statements to bring in our program user data and the display function used to console log the program output to the terminal window. As expected, the program executes 3 looping mechanisms and outputs the user ID and names of all user objects contained in the user data array. If we run the same index.ts file with Node, we will see the same output. Notice that the terminal prompt includes a pipe into the more command. This allows for paging of the program output. If the output exceeds the full length of the terminal window, the program will pause. Press of any key will continue output until the program execution is complete. The successful execution of this code demonstrates that our application has access to our simulated backend database. Now we will move on to the execution of our code in a web browser. The file output to html.ts includes all the code used to dynamically create a full web application including all HTML components, user data, and functions. However, this TypeScript code must be compiled down to JavaScript in order to execute in a web browser. As part of the workflow of a TypeScript application, it is useful to define build scripts in a package.json file in the root of the program directory to handle the necessary program processing steps to compile and execute the code. If we open the package.json file in the root of our program directory, we see a variety of node configuration options. Notice that the project type is defined as module. This flag must be set in order to build code using the ECMAScript modules using import and export statements. There are also a number of convenience scripts defined in this file. Let's look at the script named server. The execution of this script will perform all the steps necessary to compile our TypeScript code and execute in a web browser. From left to right we see that the script executes the following commands in sequence. pnpm run type check. This command uses TypeScript tsc to check for data type errors in our TypeScript files. If an error is detected, the script execution will terminate. pnpm run remdir. Remdir runs a JavaScript program with Node that will remove the dist directory, making it ready for a fresh compilation of our project files. pnpm run asbuild. Asbuild is the tool we are using to compile our TypeScript. All TypeScript files in the SCR folder are compiled to JavaScript and copied into the dist folder. pnpm run import path update. This script is used to change the file extensions on the import statements in our compiled JavaScript from .ts to .js. pnpm run server run. This script uses the Node module, live server to launch our application in a web browser. By default, live server will look for and load an index.html file in the root of our program directory. This index.html is a basic HTML page that only includes a script tag to load and execute the index.js file in the dist directory of our program. Execution of the index.js file in the browser will build all components of our web page and launch our application. Let's run the server script and examine the output. Execution of the command npm run server in a terminal shows completion of the compilation steps discussed previously. In the last step, the default browser on your computer will open and display our web application. If the application is loaded successfully, you will see the display of our seed data list of user information including ID, first name, and last name. Each line also includes a remove button. At the bottom there are input fields to add a new user. Notice that the ID field is automatically incremented for add of the next user in sequence. When we add a new user, the user data list is updated and the new user is highlighted in a yellow background. If we click to remove a user, the list is updated and the removed ID number is made available for reuse. If we look at the source code for this web application in the developer console in Google Chrome, we can see that all the components and functionality of this simple application were dynamically generated in code. The index source shows only a basic web page with our script tag used to load our application index.js file from the dist directory in the program folder. In summary, we have built a web application using a vanilla TypeScript codebase. Our data was defined in a custom type and our code organized using ECMAScript modules. No bloated JavaScript frameworks were needed. Thanks for watching.